OSIRIS-REx is a NASA mission to explore near-Earth asteroid Bennu, a remnant from the dawn of the solar system, and to return a sample of Bennu to Earth. On September 8, 2016, OSIRIS-REx began its journey to Bennu from Cape Canaveral, Florida, aboard an Atlas V rocket. It lifted off shortly before sunset, climbing eastward over the Atlantic Ocean to traverse the night side of Earth. 1 hour later, OSIRIS-REx separated from its Centaur upper stage rocket and drifted into space. It deployed its solar arrays to catch the rising sun and made a final pass over Australia before embarking on its outbound cruise to Bennu. After a year in orbit around the sun, OSIRIS-REx briefly returned to Earth in September 2017 for a gravity assist. The spacecraft passed within 18,000 kilometers of Antarctica, then turned its instrument deck toward home to capture images and spectra of the Earth and the Moon. The gravity assist bent the trajectory of OSIRIS-REx by 6 degrees, matching the orbital tilt of Bennu and sending the spacecraft on a path to catch its target. In August 2018, OSIRIS-REx began its approach phase. Its long-range camera captured the first visible light images of Bennu as a single pixel moving across a field of stars. Over the following months, Bennu grew from a pixel into a world, with OSIRIS-REx revealing its shape, rotation, and color for the first time. Now, after chasing its target for over 2 years, OSIRIS-REx is arriving at Asteroid Bennu. On December 3rd, it will fire its thrusters to match Bennu's velocity and begin its preliminary survey. OSIRIS-REx will pass high above the equator and the poles, measuring Bennu's position and mass, and refining its size, shape, and spin. On New Year's Eve, OSIRIS-REx will venture close enough to Bennu to be captured into orbit by its minuscule gravity, making it the smallest world ever to be orbited by a spacecraft. In early 2019, OSIRIS-REx will break orbit to conduct a detailed survey of Bennu. First, it will carry out a mapping campaign called the Baseball Diamond. By observing Bennu at different latitudes and times of day, OSIRIS-REx will capture stereo images and identify large rocks on the surface that could pose a hazard later in the mission. In its second mapping campaign, OSIRIS-REx will observe Bennu from 7 different stations around its equator. At each station, it will take measurements from pole to pole using its mapping camera, laser altimeter, and 2 spectrometers. The combined data will provide a detailed look at Bennu's geologic features and its composition. This will improve landmark-based navigation and enable mission planners to begin looking for places to collect a sample. Following the detailed survey, OSIRIS-REx will once again enter orbit. At a radius of only 1 kilometer, Orbital B will serve as the mission's safe home orbit until sample collection. During this phase, OSIRIS-REx will globally map Bennu. It will fly in a polar orbit as the asteroid rotates beneath, enabling full coverage of the surface. Orbital B's precession, or wobble, will also be used to measure Bennu's gravity field, along with the non-gravitational forces that are slowly altering Bennu's trajectory. In mid-2019, OSIRIS-REx will begin its reconnaissance phase. It will break orbit and fly over 4 candidate sample sites at 225 meters, taking high-resolution images. Flying at such close proximity will reveal large pebbles that could pose a hazard during sample collection. Mission planners will use this information to select the 2 best sites for additional inspection. At a range of 525 meters, OSIRIS-REx will fly over the 2 final candidate sites, spectrally mapping the surface to reveal its chemical composition. This information will help mission planners determine the most valuable site for collecting the sample. Once the final site has been selected, OSIRIS-REx will begin its rehearsal phase. First, it will practice autonomous flight to a predetermined checkpoint, where it will start its descent during sample collection. Next, OSIRIS-REx will practice flying to the match point. The spacecraft will lower to within 30 meters of the surface to match Bennu's speed and rotation, a necessity for safely touching the asteroid. Finally, in mid-2020, OSIRIS-REx will be ready to collect a sample of Bennu. Before it descends to the surface, the spacecraft will deploy its touch-and-go sample acquisition mechanism, or TAG-SAM, a new technology invented for the mission. When it reaches the checkpoint, OSIRIS-REx will begin its final descent. It will pull back its solar arrays for safety and approach the surface at centimeters per second, the walking pace of an insect. As the TAGSAM touches down, it will blow high-pressure nitrogen gas into the soil, stirring up loose material. A filter within the sample head will trap rocks and dirt while allowing the gas to escape to space. Once the sample is collected, OSIRIS-REx will fire its thrusters and back away from Bennu, retreating to a safe distance with its precious cargo. Following collection, OSIRIS-REx will verify the status of the sample using a camera called SAMCAM. This visual inspection will reveal whether any large debris is still attached to the sample head, which could pose a hazard during stowage. Next, OSIRIS-REx will verify the mass of the sample. It will fully extend its TAGSAM arm and perform a spin maneuver, measuring the change in inertia to determine the sample's mass. If at least 60 grams have been collected and the sample head is clear of hazardous debris, mission planners will command the spacecraft to stow the sample. STOWCAM will watch closely as the sample head enters the return capsule and is secured in place. OSIRIS-REx will then detach the TAGSAM arm from the head, seal the sample return capsule, and prepare for its journey back to Earth. After departing from Bennu in early 2021, OSIRIS-REx will return to Earth in late 2023. 4 hours prior to arrival, the spacecraft will release the sample return capsule, then deflect away from Earth to its final orbit as its piece of Bennu comes home. The capsule will enter the atmosphere over the night side of Earth, streaking towards the central California coastline at over 12 kilometers per second. West of the Great Salt Lake, at an altitude of approximately 33 kilometers, the capsule will initiate its parachute sequence, stabilizing and slowing its descent. Upon landing in the Utah desert, the sample will be recovered, carefully removed from the capsule, and taken to the OSIRIS-REx curation facility at NASA's Johnson Space Center in Houston, Texas. This pristine material from the early solar system will be studied for decades to come, providing clues to the formation of the planets, to the evolution of Earth, and to the ingredients that were present at the origins of life.